This is video number 4 of 5, chapter 6, functions. In this video we're going to talk more about parameters and different kinds of variables that can be used in a function, with functions including local variables, global variables, and what we call static variables that belong to a function but they retain their value. We'll see how to use all of those. We begin by talking about the ability to define functions whose parameters may be pre-initialized to default values. So let's take a look to see what it looks like. The syntax is I have a parameter name. Here's a prototype without a function name that indicates that the one parameter that this function takes, if the call does not contain the parameter will be initialized by default to 0. So if that's the case, to make the call even or odd without any parameters is the same as making the call passing it a 0. Some functions can have multiple parameters and any of them can have default values. Let's take a look at getSum. getSum requires 3 parameters. The first parameter is all of them are integers. The first parameter is required. So when you make the call, you must provide at least the first. The second 2 parameters are optional. So you can make the call several ways. I can call getSum with 1 argument, or I can use getSum with 2 arguments, and the third argument will default to 0, or I can call the function with all 3 arguments. So the rule for default arguments is that if wherever you is that when you declare the functions, the parameters that are not defaulted have to be listed first. Also, when you call a function that has default parameters, you must supply the ones that are required. So for getSum, the first one is always required. The other 2 are optional. But if you leave out the second one, you must also leave out the third. So in the second case here, we have an argument for the first parameter and an argument for the second, which is allowed because we can say provide the first. You can either provide the second or it will default to 0. And you don't have to provide the third, it will default to 0. But you cannot make a call with an empty space here. You cannot say here's a value for the first parameter, there is no value for the second, and here's a value for the third. You can't do that. Alright, so we're going to show you an example of the default parameter. So here's a simple program. The function computeSum has 2 default parameters, and therefore I can compute the sum of 1 value, 2 values, or 3 values. So let's see how that's done. The first call here, we're going to pass it 3 different values. So we're not going to default. We're going to pass it 4, 3, and 7. So we expect 14 to be the answer. The second call is where I'm omitting the third parameter. It should default to 0. So I'm adding basically 4 and 3. The answer should be 7. The third is where I am calling the function with only 1 parameter, with only 1 argument, which is allowed, again, because the first is required, the second and the third are optional. So let's run that and see what we get. Okay. And so as you would imagine, when I give it all 3, I call it passing 3, I get the right sum. When I pass it 2, I get the right sum. When I pass it 1, I get the right sum. So that illustrates the principle of a default parameter. Now let's talk more about the variables that can occur within a function. a function can have local variables, and a local variable is simply a variable that is declared inside of a block. So if you declare a function, a variable inside of the body of a function, it's called a local variable. Right? And when a function is called, the local variables are created, and when the function call terminates, the local variables go away. Right. Now, as opposed to a local variable which is defined inside of a block, a global variable is defined outside of all functions and blocks, and therefore it is accessible to all functions that's within its scope. Simply meant all functions that come after the global variable and know the global variable. Global variables are an old-fashioned way of sharing large amounts of information between functions, but it's found to be very dangerous. All right, so we want to use sparingly. Now, a local variable exists only while the function that defined it is executing. All right, so because local variables are recreated every time you enter the function, they cannot retain values. The way that we override that is to designate that certain local variables are static. And static means that the variable kind of exists all the time. It's not created and destroyed and created and destroyed. It's created only one time. Because it's created only one time, it can retain values. So the way that you declare a static variable is just to say the keyword static and then a regular declaration. You must initialize the variable when you declare it. All right? And it retains its value. Let's say this a different way. Retaining its value means that when you make a function call, you can change this variable, and the new value will be the value that you start with on the very next call. All right? So global variables are initialized to 0 or to null strings if you're talking about a string. And local variables must be initialized by the program. All right, let's give you a quick example of a static variable. Okay. Here's an example of a static variable inside of the function called total, and its name is running total. And so it looks like the function total will maintain a running total. You give it a value x, it will add x to the running total, and it will return the running total so far. And this is all possible because running total has been declared to be static. It remembers old values. So let's take a look at what we would expect to happen. The initial value is 0. So if I call total passing it 0, what happens? I'm going to add 0 to the running total, which starts off at 0. I'm going to add 0 to it, so the running total should be 0. Next time I call it, I'm going to pass it a 4. What about 4? I'm going to take the 4, add it to the running total, which was a 0. The running total becomes 4. I'm going to return 4. Third time, I'm going to call total passing it 7. It's going to add 7 to the running total, but the running total from the last call was a 4. So we're going to have 7 plus 4, that's the new running total, and I should expect to see an 11. So let's run that and see if that's what we get. Oops, wrong thing. So we get what we expected to see, a 0, then a 4, then 11. All this is made possible because we have a variable called static, and it basically is an accumulator that's inside of the function. All right? Now let's talk some more about local and global variables. It is possible for a local variable to have the same name as a global variable. That's no conflict as long as you understand the rule. The rule is if you have a local variable that has the same name as a global variable, while you're inside the block in which the local variable is declared, the variable that is in use is the local variable, not the global variable. So in effect, the local variable will shield the global variable if they have the same name. And let's give you an example of that. Okay, so here's the example. We have a global variable called total, and we have a variable inside of our function called total. Notice that this is not static, so this variable is initialized to 0 each time inside here. So let's take a look when we call this. What's going to happen? We call it passing 0, so we're going to take 0, which is the initial value of total, add 0 to it, return it, so we expect 0. Next time around, we're going to pass it a 4. When we enter the function, what's the value of total? It's 0, because it's reinitialized. So we're going to add 4 to 0, and we're going to return a 4. And of course, if we go in with 7, we're going to add 7 to 0, we have a 7. So without this being static, we don't really have an accumulator. All right, so let's take a look. So we're just going to run that and see what happens. And as we said, it's going to just give you a 0 all the time. And the global variable has never been changed. We're going to modify this just a little. Let's take this declaration out of play. If we do that, what do we expect to happen? Well, we have unblocked the global variable. And so let's run this, let's compile this and run it. And we're going to run it. Going to run it. And whoa, what just happened? What just happened is that now the global variable that's out here is playing the role of an accumulator, because the global variable does not go away. Its scope is from this point on. So every time this is called, the global variable still exists, and the global variable is maintaining the values. So the use of this global variable outside of the function is equivalent to the use of a static variable inside, and that it remembers things. Okay, so I think we're nearing the end. And see what we have. Now, as a rule, do not use global variables because they actually make things harder to understand than you think. Sometimes global variables are tied to functions, and one function may understand the role of a global variable, whereas another may not understand, and it may misuse that variable. All right? So we're going to end right